Have you ever just looked up at the night sky and felt tiny? Our solar system is this absolutely vast, incredible place, a swirling cosmic neighborhood that we've been trying to figure out for centuries. So, how about we take a quick tour of our home in the universe? You know, for most of human history, our understanding was all wrapped up in myths and models that put us, Earth, right at the center of everything. But slowly, over time, a completely new picture started to form. We shifted from that geocentric or Earth-centered view to a heliocentric one, a system that revolves around the sun. And really, it's that huge scientific shift that allows us to take this tour today. So yeah, this journey from myth to science, that feels like the perfect place for us to start. We're going to trace how our view of the cosmos went from ancient stories to the incredible science we have today.
Okay, so where do you even begin a tour like this? Well, you got to start at the very center, right? At the heart of it all. Everything in our solar system, every single planet, asteroid, and comet is locked in orbit by the massive gravitational pull of one thing, our sun.
Now, our sun isn't just some bright light in the sky. Astronomers call it a G-type main sequence star. All that really means is that it's in the most stable, longest phase of its life. It's this churning nuclear furnace that gives us all the energy for life on Earth. So yeah, it's literally the star of the show. And to get a feel for just how big it is, its diameter is about 1.4 million kilometers. Now, to put that into perspective for you, you could cram over 1 million Earths inside of it. 1 million! And its surface? It's burning at an average of 5,500 degrees Celsius. Just an environment of completely unimaginable heat and power. So what's fueling this incredible furnace? Well, the sun is pretty much a giant ball of gas. As you can see, it's mostly hydrogen, which is constantly being fused into helium. And that process, that fusion, is what releases the unbelievable amount of energy we see and feel every single day. All right, so as we move out from the sun, the first things we run into are the terrestrial planets. These are the small, dense, rocky worlds. Basically, our closest planetary neighbors. And first up, we've got Mercury. Now, because it's so close to the sun and has almost zero atmosphere, it has some of the craziest temperature swings in the whole solar system. We're talking from a freezing minus 173 degrees Celsius at night to a blistering 427 during the day. Talk about extremes.
Next stop, Venus. And oh man, this planet is home to one of the absolute weirdest facts in our solar system. Get this, it rotates backwards and so incredibly slowly that a single day on Venus lasts longer than its entire year. Just try to wrap your head around that.
And here we are, a familiar sight, right? Good old home, the third rock from the sun, with its constant companion, the moon. This is our home base, our point of reference, before we head out into the much bigger, much stranger parts of the system. Our final stop in the inner system is Mars. And what's so cool about Mars is that its day is surprisingly similar to ours, just 24 hours and 39 minutes long. But its year, that's almost twice as long as ours, taking 687 Earth days to make just one trip around the sun.
Okay, deep breath. We are now leaving the small, rocky worlds behind. As we journey further out past the asteroid belt, the whole scale of the solar system just changes. It becomes something else entirely, because beyond the rocks lie the giants.
So, welcome to the second half of our solar system tour. This is a totally different neighborhood. This is a realm of titans, absolutely massive planets made not of rock and metal, but mostly of gas. The sense of time and distance out here is just wild. Jupiter, the king of the planets, takes almost 12 of our years just to orbit the sun once. Saturn, with its famous rings, takes nearly 30. And as we go further out, the numbers get truly staggering. A single year on the icy, tilted world of Uranus, that's 84 Earth years. And for Neptune, the last planet out, getting whipped by the fastest winds in the solar system, one trip around the sun takes 165 years. An entire human lifetime doesn't even cover half a Neptunian year. And here's a cool little piece of cosmic chemistry for you. You ever wonder why Uranus and Neptune have that beautiful, distinct blue color? It's because of a little bit of methane gas mixed into their atmospheres. That methane absorbs red light and reflects blue light back at us. Simple as that. So we've been dancing around it this whole time, but this is the idea I really want to drive home. The sheer scale of it all. We've seen little rocky worlds and huge gas giants, but it can be really hard to actually picture the size difference. So let's try.
I mean, really, how big are we talking? How big is a planet like Jupiter compared to, say, the smallest one, Mercury?
Just look at that number for a second. Let it sink in. 2,775.
So what is that number? It's this. You could fit almost 3,000 planets the size of Mercury inside of Jupiter. It's just a powerful, humbling reminder that the difference in scale, even just between the planets in our own backyard, is absolutely mind-boggling.
So our tour ends right back where we started, looking at our whole system. But now, hopefully, we're seeing it with a totally new perspective, with a fresh appreciation for that fiery sun, for the tough little rocky worlds, for those colossal gas giants, and for the just jaw-dropping scale of it all.
And remember, this is just our tiny little corner of the Milky Way galaxy. It really leaves you with one big lingering thought, right? If this is what's in our own backyard, what other incredible, unbelievable wonders are waiting for us out there, in that great, beautiful unknown?